Okay, thank you very much for opportunity to make my presentation. My name is Mikhail Bannikov. I'm from Perm, from Russia. And the topic of our work is experimental field analysis of damage failure transition in composite material with a stress concentrator under cyclic loading using DIC and X-ray tomography techniques. The failure prediction for carbon composite is due to the complex damage evolution, and this work's objective is to clarify how accumulated damage transitions to failure under cyclic load. We achieved this by monitoring the material structure characteristics using a combined method of DIC, digital image correlation, and acoustic condition analysis. And after the stop experiment, it was made by a synchrotron in Novosibirsk by X-ray tomograph. And the tests were conducted on a universal testing machine. Here, как показать? Can you see my indicator? In the right side, it's a testing machine.
Yes.
With DIC, with thermographic camera, and acoustic emission gauge. Okay, next slide. Our fatigue test used a stepwise block loading protocol. We progressively increased the load from a non-destructive level to failure. We simultaneously used the DIC for strain field analysis and recorded acoustic emission. Each loading blocks was designed to provide stable and sufficient acoustic data for analysis, with a particularly long initial block to establish a baseline for damage. And here in black rectangle, you can see that place we was analyzed to phase portrait of damage accumulation. Here you can see phase portrait, which was constructed to the stress concentration zone. And the DIC strain analysis revealed to the critical failure transition. In the final stage, in the right side, you can see. In the final stage, the material behavior splits into these two distinct modes visible in the picture. One is a stable concentrated attractor representing the dominant macro track propagation, is from the left side. And the other is a random cloud representing stochastic microcracking. This can show the collective multiscale nature of failure, where the major crack stress field interacts with the numerous small damage events. The moment the macro crack attractor becomes dominant, it is a point of no return, and it will lead to final fracture. And our analysis with the Bayesian-Gaussian mixture models show that loading creates separate groups of small and large pores. We found that cyclic loading doesn't change pore orientation, but it radically reorganizes them. It destroys the natural pore clusters found in untested samples through the expansion and merging. This reorganization process is caused the strength reduction. These findings are key to step toward better prediction composite fail. See in this picture, you can see the fracture in a layer of composites. And we analyze special parameter, sphericity. It illustrates the pore distribution in logarithmic coordinates with respect to sphericity and size. It can be observed that the distribution of defects and the function of sphericity versus size is consistent with the power law. Here we can see that for initial specimen, we can only in the slope with a value of -1 in power. And for specimens, for probes, I forgot to say that there was different probes close to the vicinity of crack and far away from here, this the one. And we can see the close to the concentrator. We can different sphericity parameter from this slope. And we can clusterization of pore analysis can divide two clusters of different parameters by its size or its direction, and it can be divided to the two cracks or two clusters, which can be connective to these two attractors, which I was previously spec. Yes. So this methodology have been developed that links the integral structure parameters for composites with the evolution of damage under cyclic loading using a microtomography and DIC. Key failure mechanisms have been identified. Analysis of the other parameters, pore volume and surface area revealed different damage mechanisms. Under static loading, pore clustering decrease, and under cyclic loading, two distinct pore clusters form, one of which are pronounced orientation. Okay, thank you for attention. Can you make a question, please?